All right, let's look at the homework 15.8, problem number 10. All right, so let's rewrite this triple integral in cylindrical coordinates and to evaluate it. All right, so let's do that. All right, so first we're gonna sketch the region or solid. So here is the x coordinate here, x-axis, and the y-axis here. And here is the z-axis, right? And here's the origin, right? So it looks like z is equal to, so first, first integral is done with respect to z. So we have, let's see, this is a z equals 0 to z equals 25 minus x squared minus y squared. Right, z equals 0 is the xy plane, so that's the bottom. And the top is, this is a paraboloid and facing downward. So it's, let's see, z-intercept would be, put 0 here, 0 there, so it's 25. So I have to kind of rescale it, but let's just put the 25 there. Right, then it's facing down paraboloid. So it probably looks kind of like that. Right, so it's gonna go like that. Then you have this kind of a circular base there. Right, so it looks like that. All right, then let's see, y is going from here, and we're looking at here. So y is going from 0 to y equals square root of 25 minus x squared. So square root of 25 minus x squared would be a semicircle. So it's actually only take a half of that. So y equals 0, which is here. Right. Then this is a semicircle. So this guy right here is the y equals square root of 25 minus x squared, right? So we're gonna only take a half of it, so it's gonna look kind of like this. So only portion we consider would be this much. So here, this right here. Right. And of course, you're going to go all the way around there too. So maybe do it like that. All right. So this is the solid we're talking about. All right. And here, this is going to be radius is 5 here. And 5 there, and over there is -5. All right, so let's use the cylindrical coordinates to rewrite this. So this is going to be equal to, so I'm going to probably go down here. All right, so it's going to be triple integral. All right, so let's take care of the integrand. So integrand is square root of x squared plus y squared. And we know that x squared plus y squared is r squared. With the square root, you're going to get just r. Right? All right. Then we have, let's see, we have to have a volume element. So instead of dz, dy, dx, we're going to have r, dr, d theta, dz. Let's see, so there's going to be another r from the volume element, so I'm going to write r squared. And I think I'm going to do dz first. And the reason is that we know that the bottom is just the xy plane, top is the paraboloid, so it's easy to bound. And then I'm going to do a dr d theta. All right, so let's look at this. All right. So we have to do z, so we know that on the bottom, so we're going to have to start from the bottom here. So I'm going to pick any r, let's see, I'm going to fix r and theta. So fix r and the theta. So here's the r, here's the theta. So we pick this point. And the z value starts from here, which is z equals 0. Then all the way up to wherever it hits the paraboloid. So that's going to be z equals, right? So it's a 25 minus x squared minus y squared. So it's a 25 minus x squared plus y squared is r squared. So 25r squared. So we know that the z goes from 0 to 25 minus r squared, right? Right, so that will take care of that. And after that, we need to, let's see, talk about the range of r value. So we can see that the r, you can start from the origin, which is going to give you that, and then go all the way up to radius 5 to go to the edge of the, the bottom circle, right? So we know that the r is going to go from 0 to 5. All right, then after that, we know that here, I have to take care of half of it. So here, we're going to start from here. And the angle there is theta equal to 0. All right, then you have to go all the way around, actually, just halfway. So we just have to go there, which is theta is going to be simply pi. So 180 degrees. So we're going to go from 0 to pi. Right, so that's the integral in cylindrical coordinates. So we just have to evaluate it. Right, so this is going to be, right, so if you evaluate this, we have, I'm going to leave these first two integrals alone for now. And actually, this is r squared. If you take the antiderivative with respect to z, so it's just going to be a constant. So you have a r squared times z. Then you're going from z is going from 0 to 25 minus r squared. We still have dr d theta. All right, so if you plug in 25 minus r squared in there, you're going to get, let's see, 25 r squared minus r to the fourth power. Right? Then we want to integrate that with respect to r. Right? And from 0 to 5. Right? And since this has nothing to do with theta, so I can actually separate these. So I'm going to go from 0 to pi, just to d theta. Right? So then we take the antiderivative. Right? So you have a 25. And then you have a r cubed over 3 minus r to the fifth power over 5. Right? Then you're going from 0 to 5. Right? And then multiply by antiderivative 1 with respect to theta is theta. And it's going from 0 to pi. All right, so we're going to have, what's this? All right, so we're going to have, let's see, r cubed. So it's going to be 5 cubed. So it's going to be 125. Then you're going to have to multiply by 25. So you have a 25. So you have a 5 times 5 is 25. And 5 times 2 is 10. And 5 times 1 is 5, so it's 6. And then 2 times 5 is 0, and 2 times 2 is 4, 5, and 2 times 1 is 2. So you have a 5, 2, 1, 3, right? So you have a 3,125 over 3 minus, right? So you have, let's see, if you plug in 5, one of the 5 cancel out. So it's going to be 5 to the 4th. So what's 5 to the 4th? It's, let's see, 125, it's 5 cubed. So you have another 5. So 5 times 5 is 25. 5 times 2 is 10. And 5 times 1 is 6. Actually, oh yeah, oh actually I've done it here. So 625. So you have a 625. Then you multiply by pi minus 0, which is going to be pi. All right, taking the common denominator, so it's a 3. So 3,125 minus 3 times, so I have to multiply by 3. 3 times 5 is 15, and 3 times 2 is 6, so it's 7, and 3 times 6 is 18 pi. So this is going to be, all right, so there's a 3 there, right? 5 minus 5 is 0. All right, 2 minus 7, so you borrow 1, so you're going to be 3, then it's going to be 5. And so it's going to be 0 minus 8 is going to be 2, and 2 minus 1 is 1. So 1250 over 3 pi. All right, so let's type it in. We got 1250 pi over 3. All right, let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.